Hello friends, welcome to the course on C programming. This is the last video on the chapter function, and we'll be having some exercises for the sake of understanding the function more clearly. We have few examples over here. The very first example is to write a small function called add-n. We should take n as integer, and that function should return 1 plus 2 plus 3 plus up to n. So this is the main function. We have n and the summation, that s. So two variables are declared, integer, add n, integer. This is the declaration of the function. Add n is the name. I'll be passing n as integer and I'll be returning answer. So how do I read this function? Add n is a function with one argument integer and with one return value integer. Then I am first asking the user to enter n, and once that n is read from keyboard, I'll be passing to the function add n, and whatever answer that I'm going to get, that will be assigned into s, and that s is printed. So in main we have two variables, n and s. N is 5 and s. 5 means I'm going to read it from keyboard. So s is not clear, then s I'm going to compute. Then this is my function definition. The n is copied into p, so n is copied into p, so p is 5. And then what am I doing over here is, it is just a simple thing. For I equal to 1 to 5, I equal to 1, I equal to 2, I equal to 3, I equal to 4, I equal to 5. So I am adding all those i's. So 1 plus 2 plus 3 plus 4 plus 5 is 15, and the value of sum is 15. That is returned. So the value of sum is written, so it will go to s. So value of sum is written, so that sum is copied into s. So that sum is copied into s, and when I print sum, so I'll be getting 15. So output will be enter n 5 and sum equal to 15. So let's go to the next example. This is again similar to the previous one. Rather than addition, now this is multiplication. We know the factorial thing. So what is the difference? We have n and answer. Now integer, fact, integer. So fact is a function which takes one integer argument and it returns one value. Both are of type integer. We are asking the user to enter n. The n is read. Then we are calling the function with an argument, and the function will return me something that will be caught, that will be assigned into answer, and that answer is printed. So in main we have two variables, n and answer. N is 5, answer is to be computed. So in factorial function, that first n is copied into p, and then I repeat the loop p times, and I'm multiplying that f into I. So 1 multiplied by 2 multiplied by 3 multiplied by 4 multiplied by 5. Answer is 120 in f, and that answer is written. So return f. So that goes to answer. So that f goes to answer, and when I print answer, it will give me factorial equal to 120. So factorial equal to 120. The third example is little different. I want to check whether the given number is prime or not. We know that what is prime number? Prime number is something which is only divisible by 1 or by the number itself. So I need to check. So if the number is prime, the function should give me 1. The function should return 1. And if the number is not prime, it should return 0. So based on the value 1 or 0, I would come to know whether the number is prime or not. So this is my main function. We have n, which is nothing but my number which I want to check. Then status. Status would be something wherein I'll be assigning 1 or 0. So if it is 1, if the value of status equal to 1, the number is prime. If the value of status equal to 0, the number is not prime. First I'll ask the user. Okay, before that we have a definition. So is prime is a function with one argument, which is nothing but integer, the number which I want to check whether it is prime or not, and this function will return me either 0 or 1. If it is prime, it will return me 1. If it is not prime, it will return me 0. So first I'm asking user to enter the value of n, and then I'm directly calling the function is prime with n as argument, and that function will return me either 0 or 1. So based on the value, if status equal to 0, I'll print prime, and if status equal to, if status equal to 1, I'll print prime, and if it is not 1, that means 0, I'll print not prime. So again, in main we have two variables, and let's say 13, I want to check 13, I know that is not, it is prime, 13 is prime, and status is something that we are going to compute later on. So first, that n is copied into p, this is my is prime, and we know that what is the logic for checking prime. You start dividing the number from 2, you go up to p minus 1, whatever number is there, we go up to p minus 1, and the moment, if on the way, if you get that p modulo I equal to 0, if the number is divisible by the I, that means if it is remainder is 0, then there is no point in doing anything, return 0, because this number is not prime. But if you keep on doing all these option and you never get this value satisfied, then you come over here and what you return is return 1, that means the number is prime. Now let's check if the number n is 13, so I equal to 2, I less than 13 by 2. 13 by 2 actually it is 6.5, but because it is integer it is 6. So I equal to 2, I less than 6. I less than 6 means up to 5. I equal to 2, equal to 5. So 13 modulo 2, 13 modulo 3, 13 modulo 4, 13 modulo 5. So this loop will be repeated 4 times. But all the times that 13 modulo 2 is not 0, 13 modulo 3 is not 0, 13 modulo 4 is not 0, 13 modulo 5 is not 0. So it will never satisfy this condition, and it will never execute this return 0, and it will come out of this loop and it will return 1. So this 1 is written and copied into status. So this 1 is copied into status, and then I'm checking if status equal to 1. Yes, because it is 1. So in that case it will print prime. So it will print prime. Now let us take another example wherein the number is different. Say 15. Now I know that 15 is not a prime, I know that. So let's check this out. So n equal to 15, n equal to 15. Alright, so that is copied over here, and then I equal to 2, I less than 15 by 2. So first 15 modulo 2 is not equal to 0, but next time when I equal to 3, so 15 modulo 3 is 0, and this condition is satisfied. So it will return 0. So that 0 is copied into status, that 0 is copied into status, and check if status equal to 1, no, status equal to what? 0. So in that case it will come to else, and it will print not prime. So it will print not prime. So if it is 13, it will print prime. If it is 15, it will print not prime. So this is how you can check whether the number is prime or not. So now let us make one more program wherein we'll be using the same function is prime. So I'm not repeating the logic, the same function is there. I'm passing one number to be checked. The number is checked with this loop, and if it is prime, then it will return 1. If it is not prime, it will return 0. So what is this program for? Write a C program which takes two numbers as input and print all the prime numbers between them. So if I have let's say two number 1 and 100, so I want to print all prime numbers between 1 to 100. So what I'll be doing, I'll be reading two variables, let's say n1 and n2. So I'll be enter two numbers, I'll be reading n1 and n2, and then I'll be running a loop I equal to n1 and I less than or equal to n2. So for all I'll be checking if is prime I equal to 1, because if return value is 1, then and only then it is prime. So if this is the case, then print the value of I, otherwise just check for the next value of I. So it is very simple. I have just run a loop from n1 to n2, and I'm just checking every number with this is prime function. And if that function returns me 1, I'll be printing it, otherwise I'll be checking for the next value. So this is a simple logic. Now check, let us run the program, enter two numbers, let's say 12 is n1 and 40 is n2. So between 12 to 14, so this loop will be I equal to 12, I less than or equal to 40. So I equal to 12, 13, 14, 15, 16, 17, all the way up to 38, 39, 40. So for all the values of I between 12 to 40, it will keep on checking this is prime, and it will return 1 for these values 13, 17, 19, 23, 29, 31, 37. and these are nothing but my prime numbers, and for prime numbers it will return me 1, and for all other numbers like 14, 15, it will return 0. So that's why they are not printed. Only we have printed the numbers for which the function returns me 1. Now next program is GCD, greatest common divisor. So again, this is a very common logic. We can find out greatest common divisor from the given two numbers. The logic is very simple. Let's have a function called GCD, wherein I'll be passing two numbers P and Q. I want to find out GCD of P and Q. So the logic is very simple. Just keep on repeating until P and Q becomes same. If P and Q becomes same, in that case the answer is either P or Q. If it is not the case, then what do? You find out who is maximum. If P is greater than Q, then deduct Q from P, and if it is not the case, deduct P from Q. Now let's have an example. Let's say P equal to 81 and Q equal to 153. Now P is not equal to Q, right? 81 is not equal to 153, right? So in that case, who is maximum? So 153 is maximum. So deduct 81 from 153. So 153 minus 81 is 72. Now check 81 and 72. Who is maximum? 81 is maximum. In that case, deduct Q from P. So 81 minus 72, 9. Now P is 9 and Q is 71. Who is maximum? Q. So in that case, deduct 9 from 72. So 72 minus 9, 63. Again, 63 is larger than Q. So, sorry, 63, that is Q, is more than P. So again deduct minus 9. Then keep on deducting. And at the end, I'll be getting 9. I'll be getting 9 as Q. And now this Q is 9 and P is 9. So both are same. So P is not equal to Q. This condition will be false and it will come out. And at that time, what is the value of P? 9. So 9 is nothing but greatest common divisor for P and Q. So that is the answer. So 9 is the answer. Now how do I call this function? So let us write down the main function for this. So we have answer n1 and n2. The definition of function declaration is integer GCD integer. GCD is a function with two integer argument and it returns one answer. It returns one answer which is also of type integer. Then we are reading two numbers, enter two numbers n1 n2, and then we are passing n1 n2 to GCD. So n1 is copied into P, n2 is copied into Q, and then answer that what I'm going to get P is copied into answer, and that answer is printed. So output would be something like enter two number 81 and 153, and I'll be getting GCD equal to 9. This is the logic. And the last program is nothing but finding out LCM. LCM is least common multiplier. So how do we calculate it? So function is again very simple. We have two inputs P and Q, and then we find out first maximum. Who is maximum? Either P is maximum or Q is maximum. And then we have an infinite loop while 1 is like while 1 is not equal to 0. So this is an infinite loop, and in which what am I checking is if max is divisible by P and max is divisible by Q. If both these conditions are true, in that case only you break it, and in that case come out of this while loop, and the max value is nothing but LCM. Let us check with some numbers like P equal to 3 and Q equal to 4. So who is maximum? Q is maximum. So I'll be putting max equal to 4, and then check 4 is divisible by P. 4 modulo 3 equal to 0? No. 4 modulo 4 equal to 0? No. But sorry, 4 modulo 4 is yes. So one is no and other is yes. So entire condition, this AND means both the conditions should be true. So one false, other true. So max is incremented. Max is 5. Now check 5 modulo 3 equal to 0? No. 5 modulo 4 equal to 0? No. So max is incremented 6. Then just keep on doing, and when I get max equal to 12, at that time 12 modulo 3 equal to 0, yes, and 12 modulo 4 equal to 0, yes. So if both the conditions are true, then break, so come out. So what is the value of max at that time? Max is 12. So that value 12 is written. So let us write a small main program. So in main we have answer n1 n2, then the declaration of the function integer LCM, integer comma integer. So least common multiplier is a function with 2 arguments and 1 return value. Now let us ask the user to enter 2 numbers n1 and n2, and these 2 numbers are passed to function. n1 is copied into p1, n2 is copied into q, n1 to p and n2 to q. And then we know the logic, and the answer will be, the max will be returned to answer, and answer is printed. So output would be, when I enter to number 3 and 4, I am going to get answer LCM equal to 12. So with this, I summarize the entire chapter on function. The last video was on some programs to demonstrate, to exercise the functions more comfortably. I hope you have enjoyed the chapter on function. I hope that you have understood all the concepts thoroughly. In our next video, we'll be starting the new chapter, structure and unions. So I hope to see you in the next video. Until then, enjoy C programming.